Hello students, I hope you all are fine. So students, yesterday we discussed about the Arrhenius theory. Okay, that was the topic of Unit 3 Chemical Kinetics of class 12th. So today we will discuss one more theory, that is the collision theory. This theory is also belonging to the same unit, Chemical Kinetics. Okay, so students, collision theory, it is also giving us one equation. And what is the equation here? QSC. According to collision theory, K is equal to P Z A B E minus E A by RT. E A by RT. Okay. First of all, we will relate it with Arrhenius theory, Arrhenius equation. What was the Arrhenius equation? If I talk about the Arrhenius equation, Arrhenius equation was K is equal to A E minus EA by RT. Okay, so both are the comparable states, but what is the comparison between them we will discuss today. Here in Arrhenius theory, this K was the rate constant. I hope you all know. Constant. And this is the Arrhenius factor, Arrhenius constant, the exponential constant, or we can say probability factor also. Okay, and this EA by EA to power minus EA by RT, that was the action of the molecules. Action of the molecules, which are making a factor collision. Okay, so students, I discussed all about these things. Okay, but here K is the rate constant. K is the rate constant. Now, what is the P here? P is the probability factor, or we can say Stig factor. Stig factor. Okay, or frequency factor, we can say this. Okay, but this ZAB, what is the ZAB here? ZAB is the collision frequency. Collision frequency. Okay, and my E raised to power minus E by RT is the fraction of the molecule. Students, actually, in collision theory, what was there? One scientist was there. He told us that molecules or colliding molecules, atoms, these are behaving like the hard sphere. These are behaving like the hard sphere. Okay, Arrhenius told us that we will get the product if collision will be effective. Means if molecules or atoms will collide with one another with a proper amount of energy. Okay, with sufficient amount, and that minimum energy required is known as the threshold energy there. But according to collision theory, Maxwell told us that it is right. Collision should be proper. Now, collision should be proper. Okay, means energy should be sufficient there. But that is not the sufficient factor for that. Okay, so he told us that atoms and molecules are behaving like the hard sphere. Okay, when they will collide with one another, they will collide with one another in proper orientation, with the proper orientation, and with a sufficient amount of energy also, then only we will get product, otherwise no. Okay, so in collision theory, mainly it is dependent on two factors. One is the collision frequency, one is the collision frequency. What do you mean by the collision frequency, students? Collision frequency. Collision frequency, collisions. Number of collisions take place in unit seconds. In unit seconds and in unit volume. Per unit volume मीन्स पर यूनिट वॉल्यूम में एक सेकंड में कितने कोलिजन्स होते हैं दैट इज नोन एज द कोलिजन frequency. Means particles are collide with each other, but how much fluent they are. Okay, what is their frequency? Product will also depend on that factor. Okay, so according to collision theory, first one factor is the frequency factor. Frequency factor, that is the ZAB. ZAB means how much frequent molecules are collide with each other. Okay, so product formation depend on that also. And second one factor is the steric factor, or or we can say orientation factor also. Orientation factor also. So that scientist also told us that it is not only sufficient that they must collide frequent, but orientation is also a factor there. Means molecule to form alcohol. You want to form alcohol. So any alkoxide ion we will use here. Okay, any hydroxide ion we will use there. Then we can get alcohol plus Br negative. This is the reaction, students. This is the reaction. Here we are getting primary alcohol and it is the primary halide. So SN2 mechanism will be followed here. So SN2 mechanism will be followed here. What is the SN2 mechanism, students? Means backside attack will take place. Backside attack means here. Actually, this is the arrangement of the elements in bromomethane. Okay, so if you want to attack hydroxide ion, if you will attack from this side, then what will happen? Already this bromine is the electronegative element, it is halogen. Okay, so students, already it is having some negative charge on it, and this hydroxide ion is also having negative charge on it. Then they will not make product, they will they will repel one another. So no product we will get. Okay, but But if we attack the hydroxide ion from backside, okay, so easily we can do. Why? Because this bromine is the more electronegative element, so that's why it will attract the electron towards itself. Already some electron deficiency at this carbon, so easily it can take electron from this one and it can form bond with this carbon. So finally what will happen here? from backside bonding will take place. And students, final product, if I talk about the final product, then first one, transition state take place. This hydroxide ion will start to form bond, and this bromide will start to break the bond. Okay, this is the transition state. In SN2 mechanism, transition state take place there. In haloalkane and haloarine, we will discuss about that. Okay, about SN1 and SN2 mechanism. Then students, finally, it will get removed and it will form permanent bond. Then what will happen? We get OH, H, H. Means finally, we form the primary alcohol here. Okay, here you can see in means that bromide was in this side, but now alcoholic group we are getting in opposite side of this, and this configuration is known as the inversion configuration. So students, if you are going to attack this hydroxide ion from this side, you are not getting any type of the product. Okay, because this is not the proper orientation, it is the improper orientation. It is the improper orientation. That's why improper orientation. That's why we not getting any type of product here. Clear? But if you will do attack of the hydroxide ion from this side, okay, so no repulsion is there, then easily you can follow this and you will get the product. So this is the proper orientation. This is the proper orientation. So students, in collision theory, we get this equation. Okay, so in this equation, what was the told? There are main 2 points of the collision theory. Means formation of any product depend on two factors. First one is the frequency factor. First one is the frequency factor here. Okay, first one is the frequency factor. Also, what is the frequency factor here? Students, frequency factor is that means atoms and molecules will collide with one another, and they will collide with a sufficient amount of energy and frequently if they will do, okay, then we will get product, otherwise we will not get the product. Okay, so one was the frequency factor here, and second factor is the steric factor, or we can say orientation factor. So orientation factor is that if atoms will collide, let us consider they are colliding with huge amount of energy, with a sufficient amount of energy, but their orientation is not proper, then also we can't get product there. Okay, so particles should be collide with proper amount of energy as well as with proper orientation. Okay, so you will try to understand this theory only in one point. If atoms and molecule will collide with one another with sufficient amount of energy, okay, and in proper orientation only, then they will form product, otherwise not. Clear? So example you have already seen here. If you are going to attack hydroxide ion from front side, then you are not getting the product. Why? Because this is also having some negative character on that, and it is also having some negative sign on that. Okay, so they will repel one another, and if they are going to repel one another, then they will not come closer to each other, and if they are not coming closer to each other, then they can't form the product. Okay, but if hydroxide ion is going to attack from backside, okay, then there is no steric factor, okay, steric factor is negligible there, and easily it can attack on that, and we can get the product. Which type of configuration it is having? Inversion. Okay, so students, now this orientation is proper there. Okay, so we will get the product only if orientation is proper. Okay, so This was the equation. Here K is the rate constant, P is the probability factor or steric factor or orientation factor. You can say orientation factor. Okay, orientation factor. Anyone you can say. And this ZAB is the collision frequency. Collision frequency means how many collisions are taking place in 1 second per unit volume. Okay, so that is the collision frequency. And E raised to power minus EA by RT, this is the Boltzmann factor, or we can say this is the fraction of molecule which have kinetic energy greater than the activation energy. Okay, so this is all about the collision theory. Okay, so you can compare also with collision theory. And if I talk about efficiency of that, so this is the best theory as compared to this one. Okay, so Arrhenius is the best as compared to collision. It is more applicable. Why Arrhenius is more applicable? Because in collision he was considering the atoms and molecules as hard substances and means like balls. Okay, but atoms and molecules are not very hard and they are also very small particles, microscopic particles. Okay, so we can't compare with that. Okay, so this one is the more applicable theory. So I hope all words are clear to you. Thank you. Have a nice day.